Well, hi there, it's Mr. Kingsbury, and today I'd like to delve further into our factoring unit. Remember, this is our Algebra 2 class, and we're studying factoring. That's our unit. Today we're going to look specifically at factoring by grouping, and I'm breaking it into two parts. Today we're going to look at factoring when the exponent is a 3 or a 4. That's the biggest exponent, I should say. And then part 2 will be over quadratics because there's an extra step there, but I really think you're going to like it. Don't forget to put your period and the date on your notes. Very important. So let's do this. What exactly is factoring by grouping? It's actually a pretty straightforward idea. And that is that most or many polynomials are the result of multiplying two binomials. And because of that, then we can kind of take a long polynomial and to make it into smaller groups. And then if we factor out the greatest common factor, then we will be left with kind of a common factor that we can then factor out. It makes more sense when I do it than when I explain it. So how about I just jump right in to the examples? That's really what this is about. Ultimately, the idea is to take a polynomial and to make it into smaller groups, and this kind of magical thing happens when you factor the GCF out, and it allows you to get back to those two original binomials. So here's our first one. Let's look at 12a cubed minus 9a squared plus 4a minus 3. I will say that in order for this to work, you have to have all of the terms. You can't be missing an a or an a squared or x squared or x cubed or something like that. They all have to be there. You'll notice a cubed, a squared. This is actually a to the first, and technically this is a to the 0. Anything to the 0 power is 1, so technically it's a to the 0. They all have to be there in order for this to work. The first step is you simply group the first two terms and the last two terms. Now, I'm going to do that, and I can get away with that because this is a plus right here. You're going to see in a later example that we have a minus, and I'm going to do something with that because you can't just leave the minus there. The minus is attached to the number after it, and we have to make sure that it stays attached. Anyway, we don't have to worry about that here because we've got a plus between the second and third terms, so we're good to go. What we're going to do then is we're going to look at this first pair, and we're just going to factor out the greatest common factor. So let's see, I got a cubed and a squared, so I can factor out an a squared. And then I've got 12 and I've got 9, and I think the biggest thing I can factor out of that is 3. So I have 3a squared, and let's see what's left. 12 divided by 3 is 4. A cubed divided by a squared is just a. I'll bring down the minus. 9 divided by 3 is 3, and a squared divided by a squared is just 1, and 3 times 1 is just 3, so I don't need to write any x's there. Then I'm going to bring down the plus, and then I'm going to look here, and this is where it gets interesting. 4a and 3, they have nothing in common, not a thing. And truthfully, I should have given this more thought. I don't know that I really wanted to start with an example where this happens, but it does, so we'll go with it. The biggest thing that divides 4 and 3 is 1. And certainly they don't both have a's, so I can't factor out any a's. So the best I can do is factor out 1, and what's left is still 4a minus 3. Now that I'm done with that, I want to point out something. In the parentheses, I have 4a minus 3 here, and I have 4a minus 3 here. If you don't have the same thing in the parentheses, then you haven't factored the GCF correctly. You need to go back and take a look. Sometimes it's as simple as adjusting some signs. Other times there's a greater common factor that you just haven't gotten to yet. The way that you know you've done it is these two are the same. Now how I'm going to explain this is now we have, instead of two terms, now we have one super term. We've got this whole parentheses thing times 3a squared. And again, this whole parentheses thing times 1. So look at these as two super terms, and they both have something in common. They have a 4a minus 3 in common. Now, as you just witnessed twice, when I factor something out, I put that something in front, and then in parentheses, I put what's left. Well, I'm going to do that again, but I'm going to do it on a massive scale. They both have a 4a minus 3 in common. So I'm going to factor out 4a minus 3. When I do that, this creates a 1 and this creates a 1. 3a squared times 1 is 3a squared. And 1 times 1 is 1. So what I have here is 4a minus 3 in one set of parentheses. And then the other thing, the leftover stuff, is 3a squared plus 1. And those are my two binomials. That's factoring by grouping. And actually a more difficult one than I had originally intended, but that's okay. There's nothing wrong with that. Let's try another one here. We got 2x, I'm sorry, not 2. I don't know what I was doing. I got 6x cubed minus 14x squared minus 15x plus 35. So, as I said before, my first step is to put parentheses around here, and this leads to a problem with this second set. You see how I put the parenthesis between the minus sign and the 15? We have to remember that minuses are both nouns and verbs. So while this is fine when we don't have parentheses, when I put the parenthesis there, I do two things. Number one, I take the adjective away from the 15. This 15 is now positive instead of being negative like it was. The second thing is this verb is subtracting all of this. Well, I wasn't subtracting 35 before. I was adding 35. I have just changed what I'm doing with the 35, and I can't do that. That changes the whole problem. So here's how we're going to handle this. Whenever I have a minus between the second and third terms, I'm going to make it a plus, and I'm going to put a negative on the number right behind it, like that. And then I'll put my parentheses. Now I can go factor out the GCF. So I got 6x cubed and negative 14x squared. Looks like I can factor out an x squared. Then the question is, what's the biggest thing that divides 6 and 14? I believe that's 2. So I got 2x squared. And I'm going to factor this out. 6 divided by 2 is 3. X cubed divided by x squared is x. We bring down the minus. 14 divided by 2 is 7. And x squared divided by x squared is 1. 7 times 1 is 7. So far, so good. Then I'm going to factor out here. So I have negative 15x and positive 35. And I certainly can't factor out an x. I don't have any x's on the second term here. I do believe, though, that they're both divisible by 5. So let's factor out a 5. I'm going to put plus, and I'm going to put 5. And negative 15 divided by 5 is negative 3x, and 35 divided by 5 is 7. So I have negative 3x plus 7. Now let's check my parentheses. This one says 3x minus 7. This one says negative 3x plus 7. Well, that's a problem. They need to be the same, and it looks like the numbers are the same. It's just the signs that are a problem. This leads me to the second thing that you need to be aware of. Going back to the beginning here, when we first put these into two groups, this is group 1 and group 2, a good habit to get into is to compare the first terms of each and the second terms of each. If they have the same signs, you're fine. You don't have to change anything. But if, like this example, the first terms have different signs and the second terms have different signs, what you're going to want to do is make sure you factor out something that is negative. So if we do that, negative 15 divided by negative 5 is positive 3. And 35 divided by negative 5 is negative 7. Now the parentheses have the same stuff inside them. Just to jump back to example 1 for a second, see how the 12a and the 4a are both positive? And the 9a and the 9a squared, 12a cubed and 4a, I should say it right, those are both positive. 9a squared and 3, both negative. That meant I didn't have to factor out a negative. Their signs were the same, so it was all good. Here, they were different, so I need to factor out something with a negative. Okay. So having said all that, the next question is, what do I factor out of my super terms? And that's going to be the parenthesis thing. It's going to be that every single time. Whatever's in the parentheses, That's what you're going to factor out, and that's going to be what goes in front here. And then what's left? Well, that gives me a 1, and that gives me a 1. What's left is 2x squared minus 5. And you'll notice in my examples a lot, I'll put a plus negative here, but then when I rewrite it down here, I just put minus. There's a reason for that, which we'll get to in a minute. Mostly, it's just really good practice. It's just a good thing to do. Let's do a third example. Example 3. So we have x cubed minus 3x squared minus 36x minus 108. And let's go through all of the things we need to look for. So we need to put these things in groups. This first one, not a problem. Second one, I've got a minus. So I'm going to make that a plus and make the 36 negative. And then I will put these in parentheses. All right, so let's look at the first group. What can we factor out there? I got x cubed and x squared, so I can factor out an x squared. It looks like I have a coefficient of 1 here. It means even though this is a 3, there's not a whole lot I can factor out. The only number that divides 1 is 1. So the best I can do is factor out an x squared. Let's see what we got after we do that. X cubed divided by x squared is x minus, I'm not dividing the 3 by anything, so I'll just write the 3. X squared divided by x squared is 1. 3 times 1 is 3. So I get x squared times x minus 3. Then over here, let's check this here. Our first terms have different signs. Our second terms, they have the same sign, but I don't care. It's the first terms that are a problem. If the first terms have different signs, then whatever we factor out needs to be negative. So, the biggest thing that divides 36 and 108, I got to be honest, I'm not entirely sure. I'm going to go to my calculator and see if 108 isn't divisible by 36. That's a huge number right there, so it's entirely possible. And according to the calculator, 108 is divisible by 36. That is crazy. So I'm going to factor out a 36, and I'm going to make it negative because the first terms in each group are different signs. I'm going to put negative 36 here. Negative 36 divided by negative 36 is positive 1. 1 times x is x. And then we've got negative 108 divided by negative 36. That's positive 3. I think I may have written this down wrong. This should be a positive. My bad. Sorry. So I was right. These are different and these are different. And I'm sorry, that was Siri there for a second. I don't know what that was about or why she was even activated. Anyway, yeah, this should have been a positive 108. Positive 108 divided by negative 36 is negative 3. I got x minus 3 in my parentheses. That's awesome. Let's divide both of these super terms by x minus 3. I've got x minus 3 times, let's see, those are both 1s. 1 times x squared is x squared. 1 times negative 36 is minus 36. So I have x minus 3 times x squared minus 36. And you would think that this is where we would stop. But you know what? It's not, because if you look right here, this is the difference of two squares. And I just realized you can't see anything that I'm doing. There you go. Sorry about that. This is the difference of two squares, which I can factor, right? Now, the first factor here, x minus 3, that's not going to change. X squared minus 36, though, is going to factor into two binomials. One will be addition, one will be subtraction. This and to fill in the holes, I need to find the square root of each of these terms. So the square root of x squared is x, and the square root of 36 is 6. So I get x plus 6 and x minus 6. And that is going to be my final factor, or that's my final answer there. These are my three factors. Crazy, right? Let me do a couple more examples, and then we'll call it a day, I guess. So example 4, we have got 4x cubed minus 8x squared minus x plus 1. Go ahead and make a group out of the first two terms. go ahead and make this plus and then a negative x and make a group out of the second two terms. Let's look at the first two terms. Let's see, I've got x cubed and x squared, so I can factor out an x squared. That's awesome. And the biggest thing that divides 4 and 8 would be 4. So I've got 4x squared that I'm factoring out. 4 divided by 4 is 1. X cubed divided by x squared is x. 1 times x is x. Bring down the minus. 8 divided by 4 is 2. X squared divided by x squared is 1. And 1 times 2 is 2. And we'll go over to this other one. Let's check it. First terms are different signs, positive, negative. Second terms are different signs, negative, positive. So whatever I do, I'm going to factor out a negative. And the biggest thing that divides negative x and positive 1 would be negative 1. I know it has to be negative because the signs were different. And the only thing x and 1 have in common would be 1. That's it. So I will factor out a negative 1. Negative x divided by negative 1 is positive x. 1 divided by negative 1 is negative 1. And somehow I managed to mess this one up too. That is interesting. I think that should have been a 2 right here. It doesn't change anything else. I'm very sorry. Apparently I can't, when I'm doing my... I prepped this up, and apparently I couldn't copy what I was doing very well. So then I check the parentheses. X minus 2, x minus 2. We will now factor that out. X minus 2, x minus 2. So I have x minus 2 here. And those simplify out. That leaves me with 4x squared minus 1. And once again, I have the difference of 2 squares. So x minus 2 doesn't change. So we're going to have two binomials. One will be addition, one will be subtraction. The square root of 4x squared is 2x, so that will go here and here. And the square root of 1 is 1, that will go here and here. Ta-da! Not bad. All right, last example. And on this example, I am going to ramp it up a notch. We've got 24x to the fourth minus 40x cubed plus 42x squared minus 70x. Now, truthfully, whenever you start factoring something, the first thing that you want to do is look for a GCF, a greatest common factor. And if there is one, get rid of that first. I happen to notice that these are all even, so I know at the very least I can factor out a 2. They all have at least one x. So I can actually factor out 2x from every single one of these, which is crazy. So let's see, 24 divided by 2 is 12. X to the fourth divided by x is x cubed. Minus 40 divided by 2 is 20. X cubed divided by x is x squared. Plus 42 divided by 2 is 21. X squared divided by x is x. And minus 70 divided by 2 is 35. And the x divided by x is 1. 1 times 35 is 35. So there we go. Now I can treat this like I would the problems that I've been looking at in the first 4 examples. So here's one group. Here's the other group. And let's look at 12x cubed and 20x squared. I think I can factor an x squared out of both of those. And I think a 4 as well. So I get 4x squared times, let's see, 12 divided by 4 is 3. X cubed divided by x squared is x. Minus 20 divided by 4 is 5. X squared divided by x squared, that gives me 1. And 1 times 5 is 5. Let's go to the other one. Let's see here. I got 21x and negative 35. Both divisible by 7. They do not both have an x, so I can't factor out an x. I'm going to go plus 7 times 21 divided by 7 is 3, and we're bringing down the x. Minus 35 divided by 7 is 5. So it looks like, and we got 2x on the outside. So it looks like we have factored this into 4x squared times 3x minus 5 plus 7 times 3x minus 5. And I can now factor out 3x minus 5. So what does this look like? I got 2x. I got 3x minus 5. Let's see, that becomes a 1. That becomes a 1. What's left? 4x squared plus 7. And there you go. Completely factored. Outstanding. We'll practice some more of this in class. I want you to get really, really, really good at it because it's an awesome technique, and I think you're going to do really well. So see you in class.